We've now moved through the Allard S's, and we started with some of the RS's yesterday. In terms of pricing, we went through a little bit of the differences between Allard S, the RS series, and the Power Factor Correction series. But before we skip further, on page 4, you will see they have the dual, the quad, the triple outputs. Now on that page 4 of the catalog, you see there is no triple. Okay, but although they've got small little words there somewhere, triple, RT. Now I assume you have to sniff that's a triple. But if you go to the spec sheet, you'll see there is it. But we'll go a little bit further. So here's the RD35. Okay, the summary. So one of the things I think I just need to highlight there a little bit, if you always refer to an A, it's a combination of a 5 and a 12 volt. If you refer to a B, it's a combination of a 5 and a 24 volt. And if you look there at the RD35 13, it's a 13.5 and a minus 13.5. In the past history, they used to have a product line called ID50C, ABC, but I see those models have disappeared. Now I think it's quite important that the RD35, it's a plus minus 13. It's quite important. I must actually just go and check if there's a RID still. I forgot to go and look at that. So if I'm just going to go to MeanWell, RID, sorry, just ID50. ID 50. No, I see that model has disappeared. I'm talking with old knowledge here. But let's skip that portion. So I think what's maybe important for you guys to notice on this RD model, you'll see all of them. If I look there at the RD35A, it's 0 to 4 amps, 0 to 1 amps, channel 1 and 2, 0 to 4, 0 to 1.3, 0 to 2, 0 to 1.5. I think it's got to do with the independent channel design that they've done on this thing. You'll see later when we go maybe a little bit further, there's a dual quadruples, and you'll see there's a minimum load. So this is quite unique about this series, the RD and the RID. Okay, but what is quite important, if you look at the over voltage, right, you'll see that the over voltage is only on channel 1. It's because they use the first channel to generate the power, and it's almost like a bit of a DC to DC converter on the second channel, okay? But yet it has the ability of a 0 to 1. Usually the DC to DC portion that's inside the power supply requires that the first channel gets loaded a bit. But I think they've only added the protection on the one circuit because I think they feel should it run away in terms of over voltage and a malfunction, that channel 1 and channel 2 automatically are linked to each other so that they won't run away. Okay, so that's quite important there. So if we now look at the RID, the isolated output, okay, now the only way to really go and explain to you is if we look at the electrical block diagram. You'll see there you've got the power supply that creates the voltage, and they start switching it. And then you've got one channel here and a second channel there. And if you look at a standard power supply, the RD, it's got the common V1, V2. So they don't have two independent commons. What's quite nice about this, if you wanted to do, right, you can take the V1 and shove it into the common of 2. Okay, and therefore, if you take an RID, let's just have a quick browse here. Didn't even think of explaining that, just thought of it. So if I wanted 5 volt plus 24 volt, I can get a 29 volt power supply. Okay, the only problem is you're pretty much going to be limited to that 1.4 amp. So it's not a wise idea, but because you've got the independent channel, you can do it. Whereby on the standard RD model, you cannot do that. It'll, you know, because you only have a single common point. There's physically nowhere to connect it. You see there, here's your connection. There's your common V1, V2. Okay. So from a terminal point of view, there's not, if we look there at the terminals, which is 4, 5, and 6, you'll see that those outputs are not available there. Okay, so I think that's maybe point number one, which is quite important. If we now go slightly further, if we look at the RID, they specifically focus on telling you that all using 105 degree Celsius long life electrolytic capacitors. Now, there's a slight little video here, which I think you must just go through. It shows you that basically this graph picks up. So as the temperature rises, so does your capacitance in your capacitor also. So capacitance, remember, it's the ability to store energy. So if you've got, think of it as a bucket of water. So you've got water flowing into the bucket of water and water flowing out of the bucket. But the bucket can now just handle more water. So it's more of a buffer, if you want to put it that way. Which everybody thinks and sounds nice that it can handle a little bit more. But the problem is when it gets too hot, it'll explode. It bulges on the top and the gases have escaped. Okay, and then your power supply pretty much has no buffer in it, and it starts creating all random problematic, and you can reach, for example, an overvoltage condition. So this little video there, we will not have sound now because I forgot to press the share button there. It just shows you, how that picks up, the temperature picks up and so forth. Okay. But anyways, watch it when you can, and let's take it further from there. Okay, so we've got the RID showing you that the different commonality factors behind it. So we've got the independent there and the non-independent with the RD. Is there an RIQ, an independent quad? No, there is no independent quad model. You've only got the 5, 12, minus 5, minus 12. And once again, the B, the C, and the D every time is repeated. So even if you go from a 50 watt model to a 65 or an 85 watt model, that B always refers to that combination of voltages. Okay. Maybe I see it here as well, they refer to the tolerance. Okay. Is very high, I've noticed. So channel 1, we've got a 2% tolerance. But on the channel 2, we've got a very high, 6 or 8%, okay, which is quite abnormal having such a high tolerance. Even on this one, there's a 7% tolerance on the thing, okay. So and if you look at the design of this thing, we're looking at 79, 75, and 74%.
Rhino, work number.
Okay, let me just switch this off. I'm not sure why Rhino is going to speak to me now. Okay. Right. So we've got the triple and quads on this different thing. So look at the efficiency of that thing. It's quite low. Okay, very, very low efficiency on these power supplies. So having a dual, a triple and quad is nice, but obviously losing the efficiency behind it is also not very good. Okay. So just a slight addition here. We're looking at a triple output. Remember, we didn't see it in the catalog there. But if you physically go and download the specs, and I've added it for you guys here, you'll see there is a triple output, although it's not based in the catalog there. Once again, it's the A is the 5, 12, and minus 5. The B is 5, 12, and minus 12. So a slightly different combination in a dual versus a triple versus a quad. So it doesn't mean that the A in a dual is the same as the A in a triple or quad. You must just always go and refer to that portion. But here it highlights again, look at channel 2, that the voltage tolerance is 8%. So there's a bit of a fluctuation. I do find every now and then that the clients do complain that there is a fluctuation on that second voltage. Now a lot of times that fluctuation comes from that load not being loaded enough. I'm referring to the dual, triple, and quad power supplies. But keep in mind, this thing does have a bit of a fluctuation. So that voltage can go, if we look at that specific one, RT50C, it's 15 volts. Now, if you take 8%, that's almost 10% of it is 1.5 volt. So you're almost going to have a 15 varying up to 16 and a half volts, which is very, very high. So the client needs to be made aware of that voltage tolerance that is that's floating on that specific channel, so that it's not, it's stuck to that very specific voltage. Okay, if we then see there I've written, you look at the high tolerance levels, which is quite important that you guys must be aware of. So whenever I go to the power supplies, like I've just shown to you guys, I just always launch the website, I go to the search, and I type in, for example, RT or RID, all those kind of models that come down, and it'll bring you a list of power supplies, and it's quite nice to show you the voltages, 5, 12, -5, etc. Because it's not always too easy to see the catalog, the PDF files, and we don't have all the PDF files on our server as such. Okay, so now if we flip over to page 5, you'll see that there is, sorry, not page 5, the RSP. Sorry, page 5. It's the SE series. Now the SE series is a slightly older power supply, right? They started off with the SE. It was actually a supplement designed to the PSP series. So they had the PSP 300, the PSP or the SP series actually first, the SP 500, and the SP became a PSP 500, and so they designed it. But the price of that item was too expensive, and they started coming out with a cheaper version called the SE series. And this is where we now have the SE series, which what I think is noticeable that we need to have a look at is it only has a 2-year warranty. It definitely does have the fan design in it, so there's quite a bit of a fan that's flowing through that thing, and that I think is limiting the MTBF on the thing. Okay, what's nice about it, it does have a built-in remote sense on it. It does have a DC OK signal, and it does have a remote on and off control in it as well. So that's quite nice. But just notice that the DC OK is only on the 1000 watt and the 1500 watt volume available. What I think is important that we need to highlight here is it has a switch. Now that's on the little side here. So let's just see if I've got an SE450 open up here. It doesn't show you on this side, but on the other side of the power supply, there's a little red switch that you have to switch the thing over, okay, to be able to accept 230 volt. The only problem with that is if you leave it on 115, it's going to try and do, as we refer to, voltage doubling. So there's a slightly, just to explain to you what voltage doubling means. Okay, so it's the name suggests, a voltage doubler is a voltage multiplier circuit which has a voltage multiplication factor of 2. The circuit consists of only 2 diodes, 2 capacitors, and an oscillating AC input voltage. So here's the circuit diagram of a MeanWell power supply of an SE, I think 600, this one. There's the little switch, they've got the capacitors and the diodes. So if you put it on the 110 volt here, right, and you shove 220, it's going to try and double up the 220 to 440, and boom, you're going to blow it up. And we've had many clients blow up power supplies, and then we have to go and have a look to see why did this thing blow up. But you can quickly see on the voltage doubling circuit that the client put it on the wrong setting. So it's a little bit limitations. We haven't had that too much these days where people blow up power supplies, but just be careful that you do advise someone that if it does have a switch, they must make sure that the power supply is sent or is switched on it. Now, by default, it ships from MeanWell in the 230 volt position, but you always have people with long fingers, and they also play with it quite a bit. Now, if you do notice the 1500 watt model, they do not cater for the 110 volt AC input. Now, I think that is maybe not so clear. Why? Because they could theoretically design it if they wanted to, but let's just have a look here quickly. So if you take 1500 divided by efficiency of, let's call it 88%, divide that by a low voltage of 80, so we're looking at 21 amps, and most circuit breakers trip at 16. Maybe if you're lucky you get a single phase 20 amp. They don't supersede that, which means that you supersede a single phase capability in any wiring that has a certificate of compliance in a house or a building. in terms of single phase. They don't really cater for higher. Yes, you can, but it's almost like a dedicated circuit breaker. It's not a non-dedicated, so it's very, very industrial. Therefore, they've only advised clients to do it that way. But there is a way, should you require more power, is to run the items. Actually, I wouldn't run these items in parallel. They're not been designed to run in parallel. Okay, but you'll notice there's as well a big inrush current, 55 amp or 60 amp, which is quite high. So in terms of your circuit breaker design, the client needs to be made aware of that he needs to plan his circuit breaker either a C curve or a D curve circuit breaker. If we go back to maybe training day number 2, where we spoke about the curves and the breaking capacity of the different circuit breakers. So definitely try and suggest the client go to a D curve circuit breaker when you install this, because otherwise you're going to have nuisance tripping on your actual breaker. Doesn't mean that the circuit breaker can handle more amps, it just can handle more inrush current during that 5 second or 5 millisecond startup period. But keep in mind, this power supply, and I'll come down to it later, as a almost 1.5 second rise in energy before it can actually be utilized in full power. One bad thing about the SE series, because it's so cheap and maybe an older design, it's a shutdown. So if you overload this thing, and specifically because it is high powered, 450, 600, 1000 or 1500, people love to use it with high powered product line. They love to overload it, and basically it shut down. The only way to get it on again is to repower it and put the power on and off to the thing, which is not nice, and therefore people do go for different models. But once again, if price is the issue, people do stick away from going other models, and they love then sticking to the SE450. You'll see that there is a lot of price benefit behind this specific model. Okay, so just to look at the summary of this thing is quite important. What is AC input surge current limiting? Okay, so it has, and one thing I forgot to add in here, I'll maybe add it, is what we refer to a MOV, a metal oxide varistor. So I'll maybe just send out a Rev 1 on this thing, and I'll just show you what the metal oxide varistor is. So basically it can absorb a certain amount of energy, or we call it, the energy is defined in kilojoules or joules. So if you do have a bit of a spike or a bit of an energy coming in from the primary side, it has the ability to absorb. Now it's not a surge arrestor or lightning arrestor. Now that is a total training on its own. It's actually a 3 or 4 day course by specialists, but just be known that this specific power supply can handle a little bit of surge behind it, but not a lot. What's maybe very important to see there is that we have DC ball bearing fans. Okay, now yesterday we had a quick discussion in terms of sleeve bearing and ball bearing. Now if you have a look at this video here, you'll notice there it will give you the description of the difference between a sleeve bearing and a ball bearing, where the fans, how that's made up with the sleeve and how they operate. And this is a typical graph maybe here, which is very important, showing you that at 25 degrees Celsius, a ball bearing fan should give you 95,000 hours, and a sleeve 80,000 hours, right? But the problem is that if we start looking at 60 degrees Celsius, and we've seen a lot of times these power supplies can handle the higher temperature just at a lower load, but you'll see that the ball bearing has 54,000 hours and the sleeve bearing only 30,000, which is half the amount of time. So your MTBF, your mean time before failure, will drastically reduce on a sleeve bearing fan. And that's maybe just highlighting again why MeanWell has identified that they're using ball bearing fans on this design. Right, going down again, as I spoke to you guys earlier, the setup and rise time, keep in mind 1500 milliseconds divided by 1000 is 1.5 seconds. Now 1.5 seconds is a very long time. It's 1001, 1002. That's about how long it takes before this power supply can actually do a function. So it's not something they can switch on and immediately want to run sensors or equipment. They have to wait that 1.5 seconds before that power supply can be used. Another thing which I think is important, I see it there at the moment, is the 250 to 370 volts DC. So it's a very, very high volts DC. Most people will not shove in that high volts DC, okay? But you can if you need to, okay? We spoke about this item as a big problem is the shutdown ability of it. You'll also notice that these power supplies don't really have a very low input temperature. It's not very wide. Minus 10 degrees Celsius in countries like Canada is very little. Even South Africa, if you use this on a high site, you'll find that minus 10 degrees is very easily obtained, and that means that the power supply will not operate correctly. We spoke yesterday about the amount of eons flowing in electricity, so you're definitely going to have a problem with this power supply either non-performing or actually failing. Another thing which I think we need to highlight is the only 2 Gs. We spoke yesterday about the differences between a 2G, a 3G, 5G forces, and it's nothing to do with the telecoms transmission, but it only has got to do with the G-force shock forces. Okay. What is nice about the SE, you've got the sensing circuit coming in and out. But maybe what I need to also highlight here for you guys is the fact that the input power, okay, on this specific model. So if you look at South Africa and you look at the voltages, so we sit with a nominal voltage, as we spoke about, 230 volts AC. Okay. Now 230 volt AC, especially during load shedding, can very quickly go down. I've seen it at my house at 160, 170 odd volts. Okay. So what they show you here, this is now 180 volts, which is easily obtained during load sheddings. You can only load that power supply to 70% power. Now you ask yourself the question, why? Why is it going to happen? Right? It's actually got to do, it's not, your components are not going to overheat. It's simple. If you look at P equals VI, okay, so you require, argumentative sake, on a 1000 watt model, you require, let's call it 600 or 900 watt or 1000 watts. You're running close to the energy, but now this voltage starts dropping. So your power is still the same, your voltage is dropping, so your I goes up, it increases. P equals VI, cos theta, which is still the power factor. So, and I have a feeling this power supply is sitting at a terrible power factor. They don't state it. The only way is to test it, the actual power factor on this thing. But I have a feeling it's sitting with a terrible power factor. But what happens is that fuse, that one there in the circuit, it's going beyond its capability. And then you have the fuse popping. And that's when we start getting the equipment back. It is a blown product. It's a terrible product. But actually the design engineer didn't design his product line keeping in mind that we can go to 180 volt, which means it's 70%. Now, I spoke to you guys earlier and I said to you, keep in mind that we always would like to design a power supply to 60% power, 60% load. Now, if you keep that design in mind, the input power on this power supply would also not be problematic. So it's not from a temperature derating point of view where the components are going to fail. It's from an AC input derating point of view as well, which needs downgrading of the actual product line. Okay, now if we go look at the SE600 series, SE1000 series, it comes with a DC OK signal. Now, in the week, Rudolph was asking me for a product line where the client wanted a DC OK signal because they need to have a relay. So they switch the power supply on and off, and they need to know whether that equipment is healthy or not, or do you have your DC or not. So they have a feedback with either a little light or a buzzer or some kind of a PLC system or a SCADA system. I'm not sure if you guys are aware what SCADA systems are, but somewhere someone is monitoring this stuff and saying, listen, it's detrimental for the power or the unit not to work if it doesn't come on. So they've got that DC OK signal. Okay. Here I've just highlighted to you again the 250 to 370 volts DC, very high input. And now the homework I'm going to ask you guys, it's somewhere in the catalog. What power supply can supply me a high voltage DC so that I can power a power supply with a power supply? So someone needs to go and find out that model for me that we can run that with. Okay. Once again, it's shut down. The DC OK signal. Okay. PCU turn on 3.3 volts to 5.6. So it's not a potential free on this specific model. Okay. The SE. It's actually a voltage. And that voltage is found on the power supply there by that little connector there. Okay. Now you ask yourself the question, what am I going to do with a little voltage? Now that voltage is actually used in a transistor logic that someone uses somewhere else. Okay. Now someone's going to ask me, what is transistor logic, TTL logic? And I know most of you don't know what that is, and therefore I found you a little video to explain to you what TTL is, but I'll show that to you just now. It's somewhere down on the email here. Okay. So once again, you'll see there, this is the power supply, there's the connector, you've got your ground, you've got your DC OK signal, which is a TTL with a voltage. So it's going to give you between ground and OK a voltage, okay, between 3.3 and 5.6 if it's good, and if it's not, that voltage is going to sit at between 0 and 1 volts. It's not a relay and output. Okay. Once again, also on this specific model, this SE 1000, your remote control to switch the thing on and off is also a voltage, right? So if you want it on, it must be close to 0 volts. If you want it off, you apply a 4 to 10 volt power. I actually always thought that was the stupidest design out there, but it seems to be what they came up with on that specific item. But it seems to work for them. So you need an external energy source, like a secondary power supply, that you need to supply that, let's call it 4 to 10 volts, to force it off. Okay. So you're going to have a switch switching it on and off, but you have to supply that secondary voltage to physically switch the power supply off. Okay. Keep in mind, once again, it's this cheap series, the SE series, where they've decided to work on that kind of design. It's from electrical design acceptable, engineers know what to do with it, but from a practical or easy or cheap installation secondary of the power supply, it adds cost to it to have that energy source, because some people would almost want to supply you with, can't use a battery because a battery is 12 volt, but they're going to have to find that energy source. Okay, so I think maybe what's quite important, and we almost finished with this training, is the on page 6 is the PSP series. Now the PSP series is that square little box, or that ugly design. It's a very, very old design. It's at least 20 years old. Okay, this power supply was very prominent, or the actually old SP500, prior to any of the Dunrail power supplies that came out. So I had quite a bit of discussions with MeanWell at that stage in 1996, 1997, to ask them to please design a Dunrail power supply. And at that stage, that's why I started the Pulse range, because they didn't have Dunrail. And then afterwards, they started coming and they modified this SP series into a Dunrail design, and that came out, became a very prominent and profitable product line for them. Maybe a few highlights of this item. You'll see this is the PSP 1000, not the 600. Okay, so it's King. You see the little red there. It's got a 5-year warranty. Okay, which is very abnormal, especially if you look at the other items. The SE, I think the SE doesn't have 2 years. It only has 2-year warranty. Okay, so it's very, very low in terms of that thing. Okay, and then also you can do current sharing. with this power supply. That's if you want to put 4 of them in parallel. Okay, so you can get 4 1000s will give you 4 kilowatt, or 4 600s will give you 2400 watts. Okay, but maybe why it's quite important here is you'll see the voltage adjustment range on this product line here, on this 1000. I did not check whether the 600 does it as well, but I know specifically no, it doesn't. So yeah, the 600 was the older design. It only has 10% output. Okay. Also notice there, the 124 to 370 volts DC is right down again to a lower voltage. Okay. But on this 1000 model, is that 17% is, if you take the 24 volt model, okay, that 24 volt model there, plus 17% will give you 28 volts. And what is 28 volts? It's typically what you would be charging a battery with, or 46 to 56. So you're sitting at a battery charging voltage. Now, one of the most important things of this power supply is that there. It's called a parallel function. I don't have the schematics of this power supply because MeanWell doesn't give it out to you. But it most probably has a blocking diode design on the output because of the parallelability. So you can put power supplies in parallel. There's a little picture here somewhere. No, I'll show it to you later. There's a power supply that you can connect the 4 without blocking diode, so you don't need a blocking diode, right? Because it has that ability. Most power supplies, any power supply that you want to put 1 or 2 or 3 or 4 in parallel, needs a blocking diode. Otherwise, the energy from the one power supply flows into the energy of the other power supply if switched off, and the feedback resistor burns out, and the power supply then renders it unusable. Okay. So therefore, this thing is important to show you that it has the parallel function. If you look there at the screen, the yellow, I've highlighted to you. It's a parallel power supply. Look at it. It's got the 290 to 264 volt AC input, so we don't have the problem of that what the SE range has. Okay. It can also operate at minus 20 degrees, which is fairly normal again. Okay. You look at the efficiency is 94%. And you can run the 3+1. I don't know why they refer to the 3+1. It's almost like redundancy, N+1. Maybe they're referring to redundancy. But I don't understand, because redundancy, you need a blocking diode. Should the one go down, it's not going to drag the other power supplies down. So the word 3+1 for me doesn't make sense. They should have just used the word 4. The vibration on this thing is also very low. It's 2 Gs. I think it's got the design with the little boards. If you ever open up a SP500, you'll see they've got 2 main boards and then horizontal little boards between it. And I think those boards can't handle the vibration, and therefore they break down. I've highlighted that PWM at 90 kilohertz and the power factor at 65 kilohertz. To tell you the truth, I actually have no idea what it is. I still wanted to figure it out, but I maybe must ask MeanWell about that. If you look at this power supply here, we're looking again at the low input voltage. At 200 volts, you're still sitting at 100%, but there's only a slight decrease at, let's call it, about 180. So 180, you're still sitting at, or let's call it 95% load. So a major low voltage, like we are experiencing in South Africa during load shedding, the low voltage, we don't have to derate this power supply. It has the ability to handle it much, much better. Okay. And keep in mind the 12 volt versus the 24 volt models. In terms of derating in temperature, there's quite a bit a better performance between the high voltage models and the low voltage models. Okay. What's nice about this power supply, the PSP series, is the remote on and off is just a switch. There's no transistor logic. Okay. And there I've got you the slight little video there for you guys of what TTL is. A transistor is a device that can be made to behave like a switch. Okay. So just have a look at that little video if you can there. The power OK signal on this thing again is TTL. Okay, so they haven't gotten away with having a potential free, so some kind of a TTL signal will have to be used behind it. Also, they're showing you that there's, yeah, here it is, what, why no blocking diodes? It's got to do with the design there with the blocking diode built in. I think it's that 40Q, the same that we wanted to use, Simon, on that battery charger the other day for the Blue Nova going to the island. So I said sometimes they build those items into the power supply. So I think one of those devices, that 40QF something, is built into this thing. Okay, so it can handle the power, it can handle the cooling behind it. Yeah, and that's it, me folks, 35 minutes. I haven't kept you too busy. And hopefully you guys could follow what I've said. Maybe go through the video. I'll post the video slightly later if someone wants to re-listen to the video. But get to know the PDFs. Maybe open up those spec sheets, read through them, make sure that you understand every specific item behind it. Go to the website, download more specification sheets. Make sure that you actually go through the specification sheets one by one. That's the only way you're going to get your knowledge up. Okay. So yeah, next week one-on-one training a little bit there, or one-on-one double checking rather than training. That'll give me some time to prepare again for the week there afterwards, because I don't like to just slapdash. As you can see, I quite break through with the power supplies, and I go in depth so that you guys can fully understand what is happening. Any questions at this stage?
Yeah, I did have one. Recently, dual outputs, when you adjust the voltage, does it affect other outputs?
I must actually look if that thing has two pots or one pot. I think it has one pot. So, yeah, there's only one pot there, so it definitely will adjust the channel on both. Correct. And it's also that AC, that DC design. So if you go from 5 to 5.5, let's just see. What's the voltage? Voltage adjust. No, I lie. It says the voltage adjust channel 1. So only channel 1 is adjustable. You see it there in the spec sheets. You see there. Only channel 1 has it. Maybe that's the RID. Let's just look at the RD. Yeah, the RD also has only channel 1. Okay. You'll find most of your answers in the spec sheets. You must literally just go look at a model and change it. Okay. Lekker. Thank you very much, and enjoy the day. I'll be in the background. I'll definitely be working with all of you guys all the time. Cool.
Thank you.
Okay, bye-bye.